And welcome back to module number 6, which is about adding a database layer. It's a Amazon Cloud Architecting certification. We are covering the knowledge check questions with explanation of right answers and why other answers are the wrong answers. So let's go through question number 1. It states that which statement that compares a database service that AWS manages with a database on an Amazon EC2 instance is true. So the right answer for this one is AWS manages database patches for a database on a managed database service. The reason is that when you use AWS managed database like Amazon RDS or Aurora, AWS handles the heavy lifting for the database engine, patching, and minor version updates. You still choose the window, but the patchwork is on AWS. Now let's go through the wrong answers and try to understand that why they are wrong answers. First of all, the first wrong answer is that configuring backups for the database on a managed database service isn't needed. That's wrong because backups are still your responsibility to enable and set retention for. Managed doesn't mean no backups. It means that backups are built in and easy to configure. Then if we look at the second option over here, which says that AWS manages operating system patches for the database on an EC2 instance, it's incorrect because on EC2, you own the instance that includes OS patching, database install, and maintenance. Now, third option, which is wrong, is configuring backups for the database on an EC2 instance is it needed. This is absolutely needed. If you are using it, you must design and run it yourself on EC2. After that, we have question number 2, and question number 2 says that a small startup company is deciding which database service to use for an enrollment system for their online training website. Which requirements might lead them to select Amazon RDS rather than Amazon DynamoDB? So the correct answer is the data is highly structured. That is the first answer. Relational schema, strict relationships, and SQL are naturally fit for RDS. The second answer is student course and registration data are stored in many different tables. The reason is that multiple related tables joins part to a relational model. Again, RDS is a territory. Let's see the other options. The enrollment system must be highly available. That's wrong because both RDS, which is multi-availability zones, and DynamoDB can be highly available. This doesn't decide between them. The other option is that data and transaction must be encrypted to protect personal information. Both services support encryption at rest and transit, and then data must be backed up in case of disasters. Both services offer backup capabilities: RDS automated backup, DynamoDB PITR, and on-demand backups. After that, we have question number 3. A startup company is building in an order inventory system with web front end and is looking for a real-time transactional database. Which service would best meet their needs? So the right answer for this one is Amazon DynamoDB. For millisecond at-scale transactional workloads with simple access patterns, DynamoDB gives you the consistent low latency and elastic scaling. Now let's go through the other answers. We are not selecting Amazon Neptune because this is a graph database for relational and graph queries, not a general transaction key value or no SQL store. So we cannot select this one. The other one is Amazon Redshift. We are not selecting this one also because it's a database warehouse for analytics or OLAP, not for real-time transactions or read and writes. And we are not selecting Amazon DocumentDB since document stores for JSON documents while transactional features exist. It's not the best fit for the high throughput key value style inventory system compared to Dynamo database. Next is question number 4. A small game company is designing an online game where thousands of players can create their own in-game objects. The current design uses MySQL database in Amazon RDS to store data for players' created objects. which proposed online game object feature could make Amazon DynamoDB a better solution? So the first right answer is a high amount of read activity on player created object and a low amount of writes. The reason is that read heavy, low write patterns with predictable key access scale beautifully on DynamoDB. The other right answer is unpredictable object attribute for player created objects. The reason is DynamoDB's schema flexible items handle variable attributes cleanly without schema changes. Now let's go through the wrong answers. We are not selecting the first option as a set of common object attributes for player created objects. The reason is that it attributes and uniform and relational queries are needed. Staying with RDS can be fine. And for the other option which says that game items that can be modified using the data contained in other tables, we are not selecting this option also because cross-table joins favor relationships databases like RDS, and we are not selecting the last option which says that the game data items that include binary data and might exceed 700 ME. DynamoDB items are limited to 400 KB. Very large blobs don't fit. Question number 5 says that an organization is concerned about an increase in fraud. Which service could help with building real-time graph database queries for fraud detection? So right away, the right answer is Amazon Neptune. Fraud patterns are naturally graph shaped. Neptune is built for fast graph queries and connected databases or connected data. Now, the first wrong answer which they showed over here is Amazon RDS. We are not selecting is because general relational engine is used in that one and it's not optimized for graph traversals. And Amazon Redshift isn't the right option because it's used for analytical warehousing, great for business intelligence, not graph queries in real time. And we are not selecting DynamoDB as well because it's a NoSQL store, not a graph database. Question number 6 says that a data engineer must host a new Microsoft SQL Server database in AWS for a project. Which service could they use to accomplish this task? So the first and the only option available in this one is, so the right option is Microsoft Aurora. The reason is that Aurora supports MySQL. And then the other answers which are available are wrong because Amazon Neptune is not the right answer because it's used for graph databases. We are not selecting DynamoDB since, as we covered earlier, it's a not SQL server. And then DocumentDB isn't the right option because it is basically dependent on document database. Question number 7 says that which technique should be used to secure Amazon RDS database? So there are 3 options in this one. So the first option is security group to control network access to individual RDS instances, lockdown who can connect to the network layer. Then the second right option is a virtual private cloud to provide instances isolation, place the database in private subnet and control the routing. And then the last option is encryption both at rest and in transit to protect sensitive data. The reason is that enable storage level encryption and enforce TLS for connections. Now let's go through the wrong answers over here. We are not selecting an Amazon Virtual Private Cloud, which is a VPC gateway endpoint to prevent traffic from traversing the internet. The reason is that the gateway endpoints are for S3 or DynamoDB, not for RDS. Now, we are not selecting the option of AWS IAM policies to define access to the table, row, and column levels. The reason for that is IAM doesn't enforce SQL level row or column permissions in RDS. That's handled by the database itself. And if we'll explore the option for a virtual private gateway to filter the traffic from restricted network, it's not the right option because the virtual private gateway is for VPN connectivity into the VPC, not database security control. Now question number 8 says that which technique should be used to secure Amazon DynamoDB? Now again, there are three answers. AWS Identity and Access Management is the first one. It's the policies to define the access to the table, item, and attributes level, because fine-grained access with IAM is in DynamoDB only. Now, the other answer is encryption to protect the sensitive data. It uses the encryption at rest and TLS in transit. And then the last option, which is the correct answer, is an Amazon Virtual Private Cloud, which is VPC gateway endpoints to prevent traffic from traversing the internet. The reason is that the gateway endpoints keep DynamoDB calls inside AWS network when coming from the VPC. Now let's see the other answers. We are not selecting the option of a virtual private gateway to filter traffic from restricted networks. The reason is that VGW is for VPN, not for DynamoDB access control. Then we are not selecting the virtual private cloud to provide instance isolation to firewall protection. The reason is that DynamoDB is a regional service. You don't place it in your VPC like an instance. And then we are not selecting the last one as the security group to control the network access to individual access, because no instances to attach security groups. Access is controlled via IAM and endpoints. Now question number 9 says that a company wants to migrate their on-premises Oracle database to Amazon Aurora MySQL. Which process describes the high-level setup most accurately? So the right answer for this one is to use AWS schema conversion tool to convert the schema and then use AWS database migration service to migrate the data. So when you are moving from the Oracle Amazon Aurora MySQL, you are actually switching database engine. That's a heterogeneous migration. The first step is to convert the schema structure so that it's compatible with the target database. That's when AWS schema conversion tool comes in. It translates your Oracle schema into the MySQL compatible format. Once that's done, you can use AWS database migration service to copy the actual data across with safety and efficiently. So in short, SCT first for structure, DMS is second for data. Now let's go through rest of the answers that why they are wrong. Now we didn't select the first option, since use AWS database migration service to directly migrate from AWS database to Amazon Aurora MySQL. The reason is that this is wrong because DMS can move data, but it doesn't convert the schema between different database engines. You'd end up with compatibility issues. The other option was that use the AWS schema conversion tool to synchronously convert the schema and migrate the data. That is wrong as well, because that's what totally opposite of the definition. SCT only handles schema conversion, not the actual data transfer. Then the last option, which is over here, talks about the AWS database migration service to migrate the data and then use AWS schema conversion tool to convert the schema. This is wrong also because this is reverse to the correct order. You can't migrate the data until the schema is ready in the new database. Now the last question, it says that a cloud architect is setting up an application to use an Amazon RDS MySQL database instance. The database must be architected for high availability across availability zones and AWS regions with minimal downtime. How should they meet this requirement? So the right answer for this one is that set up an RDS MySQL multi-availability zone database instance, configure a read replica in a different region. Now, the reason for this one is for high availability within the same region, you use multi-availability zone deployment that automatically maintains a standby replica in another availability zone and fails over seamlessly if something goes wrong. But the question also mentions across AWS region. So you add a read replica in a different region. That replica not only improves the disaster recovery, but also supports cross-region redundancy and faster read performance for global users. This combo gives you both local fault tolerance and regional resiliency. Now let's see the other answers. We are not selecting the first one, which says that set up an RDS MySQL single availability zone database instance, configure a read replica in a different region. The reason is that this improves read availability of the data, but it doesn't protect you from local availability zone failures. Now, if we'll see the second option, which says set up an RDS MySQL multi-availability zone database instance, configure an appropriate backup window. Now, that's wrong because the backup window is for the data protection, not real-time high availability across regions. Then the last option, which is over here, set up an RDS MySQL single availability zone database instance, copy automated snapshots to at least one other region. This is wrong as well because snapshots help with recovery, but they don't offer immediate failover or minimal downtime. They are manually restore options, not active replicas. So that was our module number 6 on adding database layer.